See, so K here, this is the spring constant. This is the spring constant that is used. So you have to remember the value of K, that is K is spring constant, the spring factor that we were representing. This is the spring factor. This K is representing the spring factor. And this is the spring constant, means this is specifically for spring mass. And M is the mass. Now see, if there are various springs in your system, then there can be multiple arrangements. Like if you have combination of springs in series. So in case of spring in series, you have to remember the quantity that remains constant is force. Force will be constant, that will be same if two springs or two or more springs are connected in series. So see, if K1 is the spring constant of first spring and K2 is the spring constant of second spring, and both of these springs are connected in series and the free end is attached to a mass of block X. Let's say X1 is the displacement produced in the first spring and X2 is the extension produced in the second spring. So see, since force will be constant in series, we can say X1 will be equal to minus F by K1 and X2 will be equal to minus K by F by K2. This is 2. Now see, total extension produced, whatever total extension produced will be the sum of extension produced in the first spring and the extension produced in the second spring. Like this, can I write it in this way? X
Yes, ma'am.
X1 plus X2. Now see, if I take force common, I'll be left with F is equal to minus K1 K2 divided by K1 plus K2 and multiplied by X. Now see, if you compare this with the main equation, F is equal to minus K of X. So this is satisfying the equation of SHM?
Yes.
So this means the system is in SHM?
Yes, ma'am.
Now see, whatever terms are left apart from the extension produced and the force, that is apart from F and X, and ignore this minus sign because you know this minus sign represents just the direction of force.
Yes, ma'am.
All the terms in every system that we'll be discussing, that won't be taking time, but you have to remember that all of these are the spring factor. So regarding spring, which are connected in series, which was initially K, now it becomes K1, K2 by K1 plus K2. Had there been 3 springs, then it would have been 1 by K1 plus 1 by K2 plus 1 by K3. Had there been 4 springs, then 1 by K1 plus 1 by K2 plus 1 by K3 plus 1 by K4. And so on, this will go. Since there in this example, I took only 2 springs. That's why I have taken the LCM and cross multiplied it. Otherwise, you have to remember this will be the constant now. See, understand?
Yes, ma'am.
Now see, for n number of springs, you can connect it in this way, 1 by K1, 1 by K2. Now see, if the springs are connected in parallel, you have to remember the extension or the compression remains same. Means the value of displacement that we are talking about, that is X. This X will be constant in both the terms. Means if this first spring exceeds or extends by X amount, then the second spring will also have an extension that will be having the value X. But what will it be differing in? Force. Now the force won't be F same for both of them. So if F1 is for first spring, F2 is for the second spring, we can simply write F1 is equal to minus K1X and F2 is equal to minus K2X. Now see, we cannot use this relation, total extension produced, because we know the total extension produced is 2X simply. What we can do, we can write the total force. This represents the total force of the system. So see, if this is the total force of the system, then simply you will be getting K1 plus K2 multiplied by X. So if there are n number of springs, what you can do, just simply add all the spring constants. That will give you the spring constant, this spring's factor value for spring mass system. Understood?
Yes, ma'am.
All right. So just note this first system. Don't write this arrangement, write this part, restoring force part.
I'm gonna scroll down. I'm gonna scroll down. Done, ma'am.
Fine. See, the next system is simple pendulum, but in this you just have to remember this formula. T is equal to 2 pi under root L by V. So now see what kind of questions you will be getting. You can see this question on. This will give you a hint. Now see, all the variations will come in acceleration due to gravity. So G, if this is your formula, T is equal to under root L by G. Now see length of the pendulum. This can be varied using thermal expansion, linear expansion that you have studied. G is acceleration due to gravity. So all the variations come from this formula. So just write down this formula.
I wrote it, ma'am.
You've
No.
written this question as well?
No, question after right now.
Okay,
Formula.
just write down the question.
Ma'am, what is the third question? Oh, free fall.
See, free fall, so acceleration due to gravity will be 0.
Yes, ma'am.
So all the variations that you have studied in those chapters, gravitation and motion under gravity, those will be considered under this.
Then I wrote the question.
Okay. So this I think you will be able to do. Just see all the variations of length will come from thermal expansion. This formula, if you remember, L naught is equal to L1 plus alpha delta T. So if it has to vary length can be varied from this. And acceleration due to gravity can be varied from the gravitational essence. Otherwise, this is the simple basic formula. Now see, regarding YouTube and 1, 2, 3 systems are left. Now see, whenever you must have done fluids, mechanical properties of fluids already.
Yes, ma'am. Hydraulic
see,
lift, hydraulic lift.
Yes, so see in that you must have done this liquid in U-tube, U-shaped tube. So now see, if we take a U-tube and we put and fill it with a liquid, and now if we apply force on one end, then once you release that force, what will happen? This liquid will oscillate like
back and forth.
Back and forth. Now see what you have to remember. You can copy down the derivation, but what you main have to remember is this part. See, once you can write it down and you will see that F is equal to mg, as you know.
Yes.
F is equal to mass multiplied by density. Now see, mass is equal to, see, density is equal to mass by volume. So mass will be density into volume. Now see, volume can be written as area multiplied by the length, height, we say. Now see, just the thing that comes over here is that if it exceeds from one side, let's say by y length, then from the other side it will be depressed by y length also. Yes or no?
Yes, ma'am.
So see, the total extension or the total change in length, this will be the whole, that is y plus y. So the total length will be? See, this is the length y.
Yes, ma'am.
This is the length y. So the total length will be?
Y plus y.
That is 2y.
2I.
So that's why we say this h or whatever is the length, this won't be only h, this will be 2 times. Because one from the depressed side and one from the elevated side. So see, mass is equal to rho A 2h. And we have S is equal to mg. So force will be what? Rho A 2hg. Now see,
Yes,
if you
ma'am.
separate length, height, y, if I write y, then see 2a rho g will be the constant. So see, you just have to remember this constant that in case of U-shaped tube, U-tube oscillating U-tube, this is 2a rho g. This is the constant. Now see, you have the value of k. You know the value of time period. 2 pi is under root m
Yeah,
by k.
M by K. Yes.
And you also know omega is equal to under root k by m.
K
So
by M.
whatever variations can come, you can put the value of k. You know the value of k now. So you should remember value of k in all different oscillating systems. Fine?
Yes, ma'am.
Okay, oscillation of floating cylinder. This is also similar to the above one also. In this, you just have to remember A sigma g comes from that part, buoyant force. Buoyancy you must have done, Archimedes principle.
Yes, ma'am.
So from there, this comes how we'll be able to substitute the value of mass. So similarly, just sigma is the density of the liquid. There, rho wasn't the density of liquid. Rho was the density of the body, of the of the U-shaped tube that was accumulating the water. Here, rho sigma is the density of water. So here the constant that comes, this will be A sigma g. See, if you take a cylinder, if you take a tub, if you fill it with liquid, if you fill it with water, and you take a light cylinder and you suppress it a bit in the water, what will happen? It will
It will,
oscillate.
yeah, it will oscillate.
It will come out and then go until the external force will balance the restoring torque. So that's why we say oscillation. A floating cylinder also oscillates. And the constant, you have to remember the value of constant, that is A sigma g. A is the area of the cross section of the cylinder. Sigma is the density of the liquid. G is the acceleration due to gravity. And rest of the things, time period, omega, that you can calculate easily by yourself. You just, main thing that you have to remember is value of K for different systems, because this is the thing that you can forget. Rest of the things you can derive on your own. You can find
Yes.
out time period, you can find out angular velocity, but K's value deriving all the time will be lengthy. And see, one more, last system is this. See, if you take Earth, if we have the Earth and we dug a big tunnel, and then a ball is passed through it. Now see what will happen. Because of this part, this lower part, the second part, this ball of mass m will be attracted towards the center.
Yes.
Now see, once it will be going down, because of this upper part of the earth will also be executing or exhibiting gravitational force.
Yes.
Gravitational force. So that's why this ball will be directed towards the center again. So by this, what happens? Mass of ball or ball of mass m keeps on oscillating because of the gravitational forces of the earth that act about its center. That's why we say a ball through the center of the earth, if a tunnel is dug, it also oscillates or exhibits SHM, simple harmonic motion. So see, the value of constant that you get over here is the K is equal to mg divided
mg
by
by
r.
R.
Now see, regarding G, again, this can be written as Gy by capital R, where G is the acceleration due to gravity on Earth, Y is the
Yes.
displacement, R is the radius of Earth. And this derivation is, you can refer to your gravitation chapter. There you must have done this variation of acceleration due to gravity with depth, with height, with altitude, with rotation. So all the variations come from there only. So mg, if g prime, that is the new acceleration due to gravity, is gy by r. So it means F will be equal to mgy by r. We just simply have to multiply this by m. That will give us the force. So the constant that is over here, this is mg divided by r. So now again, you can find out the time period and you can find out the value of angular velocity. Clear?
Yes, ma'am.
So just note down these systems. Wherever you get stuck, ask me. If you get stuck in the derivation, just let me know. Then we are left with just last topic, forced undamped oscillation, that part.
Okay, scroll down. Scroll down. Done, ma'am.
Okay, fine. Now see, a system executing simple harmonic motion is also called a harmonic oscillator. So any system that is executing SHM that we have seen, all these systems, these are known as harmonic oscillators. Now see, a harmonic oscillator means all these systems which execute SHM, these produce sinusoidal oscillations. And see, these sinusoidal oscillations can be of two types. It can be damped oscillation and it can be undamped oscillation. Now see, if there are no dissipative forces present in nature. Dissipative forces like forces of friction, which release the rest of the energy in the form of heat. Like you can say friction is a very good example of dissipative force. So what happens? The amplitude gradually, it will remain constant. There won't be any variation in the value of amplitude. Like if I say this first wave is having an amplitude of 5 centimeter from this side and minus 5 centimeter in the lower from the trough part. So throughout the oscillation of the wave, this wave will be oscillating with the amplitude of 5 centimeters. Why? Because there are no dissipative forces which can remove it in the form of heat. So see, these kind of oscillations, these are known as undamped oscillation. So frequency also remains constant and the amplitude remains constant. These two things remain constant. So see, if there is no loss of heat, so what will happen? Do you think energy will be the same or there will be variation in energy? There is no loss of heat.
There is no loss.
So there won't be a loss of energy. If the initial energy was 5 joules, and
Yes,
I
ma'am.
said there hasn't been any dissipation of energy.
So it will be 5 joule.
It will be 5 joule only. So that's why we say mechanical energy is conserved. This is also an important point of undamped oscillation. So this represents the waveform of undamped oscillation. And such oscillations can occur if frictional forces are absent. Like example is if the bob of pendulum is displaced in vacuum and then released, what will happen? The bob will continue to execute SHM of constant amplitude. Just contrary to it is the damped oscillation. In case of damped oscillation,
Amplitude is decreasing.
Exactly because of the presence of dissipative forces like friction. These are always present that dissipate the oscillating energy. So unless energy is somehow added, dissipation eventually brings the system at rest at equilibrium. So that's why the amplitude gradually keeps on decreasing, and this is how the waveform of damped oscillation is represented. So see, because there is dissipation of heat, if I say initially the heat was 5 joules and 2 joules of energy has been dissipated because of, let's say, friction, then how much energy will be left now?
3 joule, right?
3 joules. So is 5 joule and 3 joule same?
No.
No. So that's why we say mechanical energy does not remain conserved in this. So these are basic damped and undamped oscillation. But regarding damped oscillation, see, undamped oscillation is all the cases, all the topics that you have studied. Regarding damped oscillation, since dissipative forces like friction, these are acting in nature. So what will happen? Apart from the general values and general formula that you have seen, few terms will be added. Like the way you had F is equal to minus kx. Now you will be having minus kx minus b. B is the damping constant used and V is the velocity. So this is the difference that comes because of presence of the dissipative forces in nature. So now see, if F is equal to, if I transport them all together, this will be F plus kx plus bv, this will be equal to 0. Now see, I want all the terms with one variable. So let's say x. X is the basic thing, means displacement. Every larger term can be reduced to displacement. So force will be what? Mass into acceleration, and acceleration is double differential of displacement. Acceleration can be written as d square x by
dx, yeah, d square by
F
dt.
will be md square x by dt square. And velocity is dx over dt only. So see, if I substitute these values instead of f and v, it will come out to be md square x by dt square kx plus b dx over dt. Now see, if I divide this whole term by mass, This m will get cancelled.
Cancelled.
This will be divided by m, and this
Yeah.
will be having 1m extra. So this final equation that you get, this is the final equation due to damping. If you remember, till here only it was the equation for undamped oscillation, that is
Yes,
after
ma'am.
radiation. This term gets added because of damping. Similarly, displacement equation will also be having variations. Like the amplitude won't be a this time. It will be a e to the power minus bt divided by
m.
2m. This
Yeah, 2.
2m. M is mass, p is the damping constant, t is time, and e is the simple exponent that we use. Similarly, since the displacement is also not same, angular frequency and the time period won't be same. So omega was what? Under root k by m. Now
A
it
by
is minus v square
minus
by
b
4m.
square by 4m square.
And all these variations are coming due to the damping. And also we had seen energy. So amplitude will be this, energy C. In case of energy, half m omega square a square it was. Now see, since amplitude is not same, this energy will not be exactly the same. So it will be half m omega square a square to the power e multiplied by e to the power minus bt by m. So this is my m, not 2m. Because of squaring, this 2 gets cancelled. Clear?
Yes, ma'am.
You see, if you draw the graph, this will be in this form. Amplitude is also varying exponentially, and this energy is also varying exponentially. Is this clear?
Yes, ma'am.
Just note it down.
Let me scroll down. Done.
Plotted these two.
Done. Done.
Fine, Harsh. This brings you towards the end of this chapter. If you have any doubts, you can ask me later.
Mama, can you show me that question of
Which one?
This one. A simple pendulum one. I just want to like see it 1 minute.
This one?
Yeah, the answer.
Okay. See, when it is accelerating vertically upwards, acceleration will be towards the y-axis, and this acceleration due to gravity will be acting downwards. So see,
Yes.
if you use sign convention, that what will happen? One you have to take positive and one negative.
Positive, other negative.
So what happens? This gets added up.
Added
There's
up.
G effective. And when it is moving vertically down, this gets subtracted. Means acceleration due to gravity and acceleration, these get subtracted. G effective. In case of free fall, since gravitation acceleration is equal to the acceleration due to gravity, G effective becomes 0 because there is no
Zero.
difference between them. So
Yes.
see, 1 by 0 is what? 1 by 0 is infinity.
Infinity.
Get time period as infinity. And see, regarding the fourth part, if you remember from your parallelogram law, if two vectors are acting and the angle between them is 90 degrees, because see, acceleration due to gravity will be acting downwards only. This is fixed. And acceleration is acting towards this side. See, it says in this question, it is saying it is acting horizontally. So acceleration, it is acting horizontally. So angle between them is 90 degrees. So using parallelogram law, this will be under root a square by g. Right.
Okay. Okay, done. Understood now.
You've written this?
No, I have to. Mama, I'll write it.
Okay. Let me know when you are done.
Okay.